Good evening, everyone. My name is Aman Maurya, and today we are going to study what is a deadlock in operating system. It is a concept that can occur when resources are being shared between multiple processes. Imagine this: a computer is running several programs, but suddenly some of them stop working because they are stuck, waiting for each other to finish using certain resources. This situation is called a deadlock. Now, let us see an example. Two people are sitting in a hotel. Let's call them person A and person B. On the table, there is only one fork and one knife. Person A has a fork but needs the knife to eat. Person B has the knife but needs the fork to eat. In this situation, neither of them can eat because they are both waiting for the other person to give up the utensil they need. This situation is called deadlock. Both are stuck, waiting for each other, and as a result, no progress can be made. Now let us look what is the definition of deadlock. It is a situation in operating system where a group of processes are stuck in a state where each process is waiting for a resource that holds another process. Let us see an example. A computer system has multiple processes running at the same time. Each process may need access to certain resources like files, printer, or memory. Deadlock happens when process P1 have resource A and is waiting for resource B, while process P2 have resource B and is waiting for resource A. In this situation, neither of them can proceed because they are both waiting for the resource held by another process. This is called deadlock. As you can see in the diagram, process P1 is holding resource R2 and is waiting for resource R1, while P2 is holding resource R2 and R3 while waiting for R1. In the same situation, P3 is holding R3, which is needed by P2. In this situation, a deadlock occurs and a cycle is formed. We can represent this situation with a resource allocation graph. We will study about resource allocation graph in the coming lectures. Now, let us see what are the conditions for deadlock. The first condition is mutual exclusion. This means only one process can use a resource at a time. One process, one resource. For example, a printer is being used by process P1, no other process can use it until P1 releases it. If resources can be shared, the risk of deadlock increases. The second one, hold and wait. Hold and wait. A process is holding one and is waiting for another resource. This is called hold and wait. Let us example. Process P1 is holding a file and is waiting for printer, while process P2 is holding the printer and waiting for the file. The third one, preemption. There cannot be any forceful preemption of resources. This is highly prohibited. The fourth one, circular wait. Let us take an example of three processes. Process P1 is waiting for a resource held by P2, P2 is waiting for a resource held by P3, and P3 is waiting for a resource held by P1. This creates a cycle and is known as circular wait. After this, let us move on to what is a resource allocation graph that we discussed earlier. A graphical representation used in operating systems to model and analyze the allocation of resources to process. It is primarily used to study deadlock condition and resource management in a system. In a resource allocation graph, processes are represented as circles, resources are represented as squares, edges show request and allocation, while a cycle in the graph indicates potential deadlock. It means if a cycle is going to form in the resource allocation graph, then that is a sure shot deadlock. After that, let us look at what are the strategies that we can do to avoid a deadlock condition. The first one is deadlock prevention. Restrict one or more of the necessary conditions. There are four conditions that we discussed earlier. Mutual exclusion. We can break the mutual exclusion. For example, some resources can be shared instead of being exclusive. There is no exclusion. For example, read only files can be shared by multiple processes at the same time. However, for resources like printers, mutual exclusion is avoidable. The other one is eliminating hold and wait. We can ensure that a process requests all the resources it needs at once before it sets. No preemption. This condition can be avoided by allowing the system to forcibly take resource from a process and give them to another process. And the last one is the breaking circular wait. To avoid circular waits, we can assign a specific order to resources and require process to request resources in that order. If we can break any of the four conditions, then the deadlock can be prevented. But let us say deadlock, how can we avoid the deadlock? There are algorithms like the banker's algorithm by which we can avoid the deadlock. Sometimes we don't want to prevent deadlock but avoid it. For this, we need to know in advance how resources will be used. Each process must declare the maximum number of resources it may need. The system that uses algorithms like banker's algorithm, whether granting a resource will lead to deadlock. If it's safe, the resource is allocated, otherwise, the process must wait. This approach is more flexible than prevention, but it requires additional information and careful monitoring. Now, let us say deadlock has occurred, but how can we detect it? If we don't want to prevent or avoid deadlock, in such cases, the system needs a way to detect deadlock. The system runs a detection algorithm to identify which process and resource are involved in the deadlock. Once a deadlock is detected, the system takes the recovery options are to remove the deadlock. There are two processes. We can either terminate a process or preempt a resource and free it. In the terminating process, the system can terminate one or more process involved in the deadlock. There are two ways. We can abort all the deadlock process or we can abort one process at a time. So that deadlock is resource. Terminating process can be expensive, especially if they are already completed most of their work. Another one is preempting resources. The system can take resource away from process and relocate them to resolve the deadlock. This approach requires careful planning to avoid disrupting the app system. In conclusion, deadlock is like a traffic jam in a system where processes are stuck waiting for each other. It can happen when certain conditions are met, but we can prevent or avoid it by breaking these conditions or planning resource allocation carefully. Another example from the real world can be two trains. There are train A and train B on a single track railway. Train A waits for train B to clear the track, while the train B waits for train A to clear the track. This circular wait results in a deadlock. If the deadlock does occur, we can detect it and recover by terminating process or allocation carefully. Now, I want you to write an example in the comments so that we can see what is a deadlock and please write in a real world example. Thank you.